which is the way a lot of people use it. A lot of people compare that to Django's ORM. I'm going to talk a little bit about core SQLAlchemy that we use a lot in my daily business. I'm going to talk a little bit about Alembic to handle database migrations. People often ask me, how do I describe SQLAlchemy? I think this really sums it up pretty well. It's basically amazing. It really is incredible, and I think part of that comes from the fact that the architecture is really sound, it's really compartmentalized, but they exposed it all to you. And if it doesn't do what you want to do, and Brandon couldn't have said better this morning, you can easily change it. You can easily manipulate it. If it doesn't to a database type that you want to talk to, you can change that to that. And so this will be the last one of these slides you see. But when people ask me, how can I simplify this architecture? I often think about how people talk about Git. And they talk about Git as being the porcelain of something, right? And apparently, I need to stand right here. So they talk about the plumbing and the porcelain of Git, how all these user-facing commands that you can use, but behind that, there's a whole other set of commands that if you really want to go mess with the ref log or really mess with the commit history, you can do that. And we still having audio problems?
No, if it gets too bad, then grab this.
Okay. Sorry. So I kind of think of SQLAlchemy the same way. It has a core and an ORM side. I think of the ORM as the porcelain. I think of the core side of it as the plumbing. And the great thing is you can touch both. And it's really simple to get started. So if we have just a general project that we want to have some database access to using SQLAlchemy, we can just do a pip install. But if you're doing web development and you're using a framework like Flask, there's actually a Flask SQLAlchemy that makes it really simple to tie it into your app. Or if you're using Pyramid, there's a very simple scaffold that lets you pull that directly into Pyramid. If you're using Django, just import it the normal way, and you'll be able to access it. The first thing that we've got to do when we fire up SQLAlchemy is we need to create an engine. And back on the architecture slide, there was a little thing down at the bottom that talked about the connection pool. And the engine is really the connection pool piece. It takes a dialect, which is a database language that we're speaking, and I'll talk more about dialects later. But in general, those are dialects for Postgres, dialects for MySQL, Informix, MS SQL. That's the type of database that we're going to be talking to. The driver is the usual things that you use when you're talking to driver. So MySQLD or Python MySQL or PsychoPG2 for Postgres, whatever method you'd like to use. And this creates an engine, and that engine will hand connections off to us when we need them. And we'll talk more about how those connections get used in just a second. So focusing on the porcelain side of it, the biggest part of it is the declarative piece, right? In the ORM, we use kind of a model base that's called declarative, so you'll see declarative base here in just a second. And it's a set of directives that assist us when we're creating classes, and it helps us define tables that relate to those classes. So we're going to define something that looks very much like a normal class, and it's going to go ahead and create a mapping of that against the database. So here you can see I import the declarative base from the declarative extension, and then I define a base that just directly pulls in declarative base. The great thing about declarative base is it has a number of additional parameters that you can pass to it so that you can customize it to have like a mix-in that you're using from a lower level than that. Like if you are one of those people who likes timestamps everywhere, you can throw your mix-in into the declarative base and then pull that into the base of your class. So let's talk about models. Right, said Fred? All right. So here I'm going to pull in some pieces from SQLAlchemy, like the column, the integer, strings, and I'm going to use this to in a second to define a class. And in addition to this being a class that I can access normally in Python, again, it maps it against the database so that I can use it in both places. And then in the bottom two sections, I'm importing a foreign key so I can have a one-to-one relationship with something else or a one-to-many. And then I'm also going to import the relationship and the backref options. And I'll talk more about them in just a second. So here's an example of a class that's using my declarative base. You can see I dropped in the table name so I could name it exactly what I wanted. I prefer to have mine all lowercase, and if you don't throw in a table name, it'll use an uppercase character. I defined an ID that's defined as a primary key, set a name, column, string, float, all the normal thing. And then I got down to this address section. And in the address section, I've defined a relationship here. And I've defined it as address. So it's expecting to find another class somewhere in my Python path that is called address. And you can see that by default, when you query up a user's addresses, I've got it ordered by the address ID. And then notice this bottom line that sets a backref to user, right? So what that does is now I have, when I instantiate a user class, I have a .addresses that's a list of addresses, right, that I can operate on. I can append to it. I can do whatever I want to with it. The backref also creates a reference from the address that points to the user so that I have a bidirectional connection between the two. So I'm going to define a simple init function that lets me pass in a name, full name, balance, and group to my class, to my user class, and make it so. So first thing we got to do to actually push this table or create this table as far as SQLAlchemy is called is this base class has something called metadata that stores all the information about the tables. And you know, a lot of times metadata gets described as it's a description of the data, and it is. But in this case, the metadata is really all of the SQL attributes of our classes kind of get stuck in there. In the SQL they look like SQL in that little container. So it's not just a bunch of random gibberish explaining it. If you go digging into it, you can actually get to the SQL statements that make up the elements of the class. And we're basically telling it to create everything that has a connection to metadata. And if you go back and look at my user class, you can see that the base was connected to the metadata. I'm sorry, I didn't mean to go back, cut that far. But the base was connected to metadata. And then we're creating this all on the engine. And what happens is that will go out, grab however many classes that don't exist in the database already. It'll go out and grab all of those, create metadata for them, and then use a connection from the engine for each individual class to create them. So basically creates a transaction for each one. And then we need a session. So sessions are the way that we kind of safely wrap things in the SQLAlchemy ORM, right? So they nicely created a thing called the session maker, which binds to an engine and allows us to, at will, call a session. But the beautiful thing that they did is if you send nothing to session and just take it in as itself, right? So here you can just see I've taken db equals session. It automatically creates a new one of those for each thing that it thinks should be a transaction. And it sets an auto commit for each one of those things that it thinks should be a transaction, right? Or, I'm sorry, not auto commit, auto flush for each one of those things it thinks should be a transaction. What's wonderful about that is if I do things like add a bunch of objects to the session or remove a bunch of objects from the session, it'll go ahead and flush that out so that all the other sessions that are using that same engine can see that data. And we'll talk more about that in just a second. So here's an example of how I can create some users with my class. So I've created 4 here, and apparently I'm into Mob's Diners. I don't know why. But Big Bob here, you can see we've set a balance on him to find who he works for. Then once I have created my user objects, I can add them to the session like you see here, right? So here I'm adding whatever was in user 1 into my session. And then the second line is an example of how I would delete one if I wanted to take one out of session, right? And then whenever I'm ready to actually put that to disk in the database, I can do a db commit, right? So what that actually does is it tells the session, I'm done with this. I want you to terminate this, write it to disk. And if I ask you for anything else related to this, give me a new session, right? So the session goes to the engine and says, I'm done. Close this connection. Consider the transaction good, right? Another option that some other things that we can do here are we can decide to expunge a record from the session. That removes whatever changes I've made to that out of the session so that I can continue to make changes, and those won't get persisted to the database, right, when my transaction closes. He talked earlier about having code stop when you reach an exception. What if you, like he said earlier, wanted the code to continue to go? You wanted to continue to have the object as it was before it hit the errored state, and you want it out of session so that the rest of your transaction will go through, right? A good example of this is we do a lot of healthcare analytics where I work, and I work at Stratazan in Nashville, and we do lots of reporting on state data sets, and we have every single patient. And I know you guys know that every single state stores their data the same way, right? I mean, 50 of them, 51, Puerto Rico, whatever. They all store it the same way, of course. And as you know, the government stores theirs the same way for all of their facilities too, right? And what we have to do is create a way so that if we catch a record that doesn't match the format that it should be, we use that expunge to kind of toss it out of session. Like, hey, I know you don't fit. You're not enough a statistical anomaly that I care about your one record out of my 20 million, right? So I'm going to throw you out of session. I'm going to come back to you at the end and see if there's something I can do to fix you. So the expunge lets you do that. Refresh lets you deal with a circumstance where the data maybe got updated in another session, and you want to make sure before you perform an operation on it that you have a current copy, right? So refresh just basically says, I have this object. Can you go check and make sure that's the latest thing in the database? Nobody else has updated that while I was in transaction, right? Expire allows me to do the opposite of refresh. So if I've made a change and I know it's important for everybody to see that change immediately instead of eventually, expire lets me do that exact same thing. So I can say this object is dead. If any other session tries to access this object, they need to go get a fresh copy from the database. I've touched it and changed it. It's important they go refresh it. And then, of course, when you do really bad things, there's always rollback to abort the transaction and fall out of it. All right, so let's talk about actually getting data. And getting data in this is very similar to the Django ORM. So as you can see here, I basically tell the session I want to query and give it an object that I want to query for. And in this case, I'm just grabbing all the users and printing out their name and their balance. Yes, I know that's not a Python 3 print statement. I'm sorry. So it's a very simple way to get. But let's look at something slightly more complicated, right? Because in a lot of tutorials, they show you this, and now you have all the data you need, right? But what if you want to do some more advanced things? So what we're looking at here is we're importing function and label, and function exposes all of those SQL functions that you're used to using. So sums, counts, those kind of things are all in the function. Sometimes you can use functions to do like subqueries, right? If you use like a Postgres and you're using a stored kind of P-SQL thing, you can use that to call that as well. So we're pulling that in. I'm doing a query here on user. Specifically, I want to get the group element off of user. Then I'm going to count the number of users that are in that group and call that members. I'm going to sum the balance of all those users and call that the total balance of the group, right? Then I'm going to group by the user's group, and I want all the records. And then, of course, I can iterate through the results as you see down there. I'm printing out each group, each member, and each total balance. What's kind of nice about this is notice how this is .members, this is .total balance, right? So when I use this label function up here, it allows me to say how I'm going to access that later, right? So even if you get, and I'll show you an example in a second, even if you get some weird column names, or if you get data that, in this case, we're working off a model, but what if we had unmodeled data? And I'll show you a great way to handle that later too. But what if we wanted a different name? Right? We can't really adjust the data. Maybe we're pulling it from some other database that's not ours to mess with. But the user wants to see it under a different name, and we don't want to really redo it every single place in our code. We can label it once in the query function, and it will be named that from that point on. It's smart enough to know that if I expunge this from the database, like I talked about earlier, it'll still keep the labels. It's very smart about how it handles when you rename things, or when you perform a function on them, or when you break them apart. One other kind of nifty thing that's kind of hidden, these functions like sum, they actually issue SQL that looks like the standard sum SQL. How many of you guys using the Django ORM have had the fun of trying to figure out where annotate should go to make the query not look ridiculous? How many people use the annotate thing in Django? It's an experience. It's funny that the closer you put that to the model that you're querying on, the faster the query goes, and the further away it goes in your list of chained functions, the slower it gets. SQLAlchemy doesn't work that way. It evaluates all the chain things as it goes across, and then it decides how to orient the query. Whereas Django tends to kind of orient the query as it's reading through the pipes and filters of the chained functions. SQLAlchemy tends to evaluate the whole thing, look at what the SQL statement looks like, and then actually optimize it. And in fact, one of the great things about it, as I talked earlier about dialects, is we know what runs fast on which databases, right? So we use Amazon Redshift, which is a large data warehouse thing that Amazon supports, and it talks Postgres, right? It's not an actual Postgres instance. It talks Postgres, and it has some unique things that it can do faster than you'd normally be able to do in a Postgres database specific to data warehousing. Because the way we use SQLAlchemy, we can build a dialect that talks specifically to that. And I'll actually show you an example of how we use it here in a bit that lets us take advantage of those specific faster functions, right? One of the nice things is if you have to dump the CSV out of Postgres, you kind of need to pull all that in, right? If you're doing it in a web app, pull all that in and then render it out to a CSV file. Well, Redshift said we're a data warehouse. People are going to dump data all the time. They have an unload command that dumps data straight to S3 in a CSV format. So we wrote a dialect that allows us to use that command, right, to leverage that. So it's very smart about handles things, and if you label things, it keeps them even once they're removed from the rest of the SQLAlchemy session or where they seem like they would be detached. It still keeps track of making sure that they all line up. All right, so let's talk a little bit more about relationships. And relationships in SQLAlchemy are basically treated like lists, right? So we can append to them very simply. We can del from them. We can do all of the normal things that you would expect from a list, and we can access them just simply by calling their name, and it will return a list to us. We can also, even though we're not in a query, we can continue to, because everything's always associated back to the session and we always have query capabilities, even though here we grabbed a user object we were dealing with as an address as a list, we can still apply pipes and filters to that to continue to refine that. Here you'll notice I used the .1. There's an E here with the braces. Normally. Here you can see that I use the .1, and that will say, give me one result. If there's two, throw an error. This guy shouldn't have two home addresses, for example, in this case, right? There's also things like .first. You can say, just give me whichever one responds to home first, some things like that. So let's look at a query involving relationships. So here again, I'm using the query directly off the session. I'm basically telling it, I want you to query users and addresses. I want you to filter it where the user ID matches the address user ID. I want you to filter it where address, email address equals this guy. And I want you to return me all the records that match that, right? And this is kind of a long form way of doing this. I could have easily said, I could have easily done this a different way. I could have done it in Python for that matter. But what's kind of nice about this is it shows how it works. I could replace this entire filter statement right here by saying users, close print, and then do .join and addresses, right? And that would do that exact same thing because I defined that foreign key and that primary key when I define the relationship, right? So I could easily take where I'm doing this query against users and addresses and then filtering myself for the join. I could also say user.join addresses, and it would do the same thing. But sometimes you really need to do things that defy nature. And SQLAlchemy thought about that, and I'm not for sure what perverse thing created that in their mind, but it's amazing. They created this concept called the hybrid property. The hybrid property allows me to define a function that acts like a property of the class that I'm working on. Okay? So here you can see it talks to self, and this would be inside my class definition, right? And this allows me to define, in this case, I was pretending it's an order. This allows me to define things like, I want a grand total, and that grand total should reflect the cost of the merchandise, the tax on it, and the shipping, right? And this allows me to have that defined as an attribute. So I can say order.grandtotal, and it knows to actually go run this hybrid property. The only requirement for this is it must return something, right? You can't have it return none. So any kind of code that you can imagine that you want to operate within your class as a property of that, you can have execute here, and it must return something, right? So it must give a value back to the user is kind of the only restriction when it comes to this. So it's pretty useful for maybe I want to amalgamate a bunch of invoices together for a month. So I can define things like, this is how much you spend in this time period, right? So that the guys who maybe are making JSON calls or touching the front side of my application, they don't have to think about all the data that's behind it. All they have to do is know that if they call, I'll give you an example in our world, if they call like patient.visits, right? They don't have to care that we are on the back end side adding up how many inpatients, ambulatory, outpatient, and orthopedic visits they have. All they want to know is how many visits did they have. And they won't have to write a query to do that because hybrid properties allow you to kind of abstract that away from them. All right. But then the universe is kind of large. right? And the ORM is great, especially when you get to define the classes, right? And this is the thing about Django's ORM too, is it's excellent when you get to define the classes. What do you do when you have unstructured data? And unstructured is a relative term, right? What do you do when you have data that comes in a variety of different databases and isn't consistent? So this is where the plumbing comes in. And this is where SQLAlchemy Core comes in. So if you go to the SQLAlchemy website, all the ORM stuff is on the left. Start there. It's good stuff. And then the core stuff's on the right. And we define the same engine that we used before, but that's about where it stops. We're still going to pull in like the standard things like tables, columns, all those things. We still need metadata, but notice the difference. No longer am I calling a class, right? In this case, I'm defining a table using basically a list of columns or a comma-separated group of columns, right? And I'm attaching it manually to the metadata, as you can see there. Still call my metadata.createAll to like go enforce that such a thing exists, and I still create the connection. But my structure becomes greatly different, right? Because now I tend to start my queries and my operations from the object itself I've defined, right? So here you can see I'm using users.insert.values to set name and full name. And notice how I have to do connection.execute now. There's no more DB commit. I've lost the way that I was doing sessions and all that stuff in the ORM has kind of gone out of the way. There's a bunch of different ways to do inserts, depending on what you prefer. So these are functionally the same thing. So basically, except for different objects, obviously. These guys are inserting the values in the insert statement. This is basically adding the values as a parameterized thing. So if you're used to seeing Postgres and doing, colon parameter name and then adding the parameters at the end, that's basically what the bottom part is. The first part's more like putting the values at the beginning. And then if you want to be really lazy, you can just put them all in the execute statement. So this basically says, go insert something into addresses. Here's the dictionary that needs to go to those guys, and it's matched up against the actual column names. And I mentioned earlier, what do you do when you don't know about the data that you're having, right? So Blue Cross gives you access to their healthcare database, and you're like, yes, because I have billions of records, which not big data, but close enough. But you're like, no, because they didn't give you the schema. So SQLAlchemy Core has a way to deal with that, and it has the ability for us to take a table, right, and pass it a table name, tell it to hook that table name up to the database, make the connection through the engine, which we would have defined the connection string in, and then just auto-load whatever's in that table. Just whatever's there, give me an object and metadata I can play with, right? Does everybody follow that? So just give me a representation of the data. I have no idea what's in that table. Just give me something.
Just the equivalent of Django's inspect DB.
Very similar. Yep. So we can take that. Here you can see I'm passing a table named census. So recently in Nashville, we had a Hack Nashville event, and we did an inclusivity index that used the American Community Survey from the census data. And as you can imagine, censuses for all the states are also perfectly the same. And to check it, what we needed to do was make sure that when we built our introspection of the table, that it actually knew all the types, right? Because what if they told me they were using Microsoft SQL Server? Well, is that anything from 2003 to 2012, right? There's a bunch of different types of columns between those types of databases. Even strings and integers aren't the same across all those variations. And sometimes we might pick the wrong dialect, or we picked a dialect that kind of got the most of it for what we had available, right? It takes a while sometimes for a dialect of a particular version of a database to be available. Not long, just takes time. What this does is it goes through each column in the table's columns, and if it's not a null type, right, or if it is a null type, it adds it to a field that says, don't touch this, we don't have any idea what the data is, right? So we're basically grabbing all the stuff from the table, mapping it into an object. If we don't know the data type that's behind that field, if we couldn't figure it out, then let's just put it in unavailable fields so we don't mess with it. So that's where the dialect thing comes back in. And I mentioned earlier that dialects give you a way to talk to different databases. So like we've created a custom dialect for talking to Redshift if you need to talk to Redshift. And there's a bunch of different ones. There's Informix, MySQL, Oracle, Postgres. But the customizable part of it is just what makes it so amazing to me. So we can take something like Redshift, where it's sort of Postgres, but it has columns that aren't the normal way, and allows us to write select statements like this. Now, this looks nasty, I know. I was trying to get it to fit on a slide, so that's why everything's letter dot letter. But trust me, there's a column called race. There's a column called factor. We wanted a sum of how many of them there were, labeled as summary. We wanted to know where the value was of the poverty type. We wanted to group by race and by the factor, and then order by race and factor. So what this query was doing is it took that American Census survey, right? We read it into an object called g.t. Then we went into the columns and said, give me race, give me factor, query it all up. But what if there were some conditional things, right? And this is the part, wow, that didn't fit on the thing. This is the part where it becomes really powerful, because now I can say, what if I don't have total charges, right? What if that total charges was an unavailable field? It gives me the ability to do kind of a query builder thing, kind of ad hoc, to say, if it's not there, we'll just skip it. We'll leave it out of the query, and we'll move on. What's also awesome about this here is you can see I'm adding total charges column, and I'm summing it, I'm doing operations on it. But this conditional S right here, where we're coming this, and then we're appending this onto the query if it's present, that conditional chaining right there can do things so that we can take a data set we do know and then make it like a query tool, like a pivot table tool like we have in Excel or some things like that, so that users feel kind of familiar with that. What's nice about it is it's not just columns that I can put in. I can extend the query in any way, right? So I could go back and say, not only do I want the column, but I'd also like to order by that column, right, if it's present. Does it make sense? All right. So what about migrations? We got all the way through the database stuff. Let's talk about migrations. So Alembic is the system that kind of works hand in hand with SQLAlchemy to do database migrations. And to get started with it, the first thing that we do is we need to initialize Alembic. So in our project root, so in a Flask project, for example, just wherever your apps are underneath it, or in Django, one step up from the managed pie if it happens to be inside, you initialize Alembic, and it's going to create a directory structure something like this, where we have an Alembic folder that contains an environment.py and a versions folder, which is where all our versions are going to go, and then alembic.ini, which is one of the places that you can configure how to connect to the database. So here's what that Alembic folder looks like in a little more detail. So here you can see I have many hashed versions that are sitting out there, and they look a lot like the Django thing. So they have a hash and then kind of what they did, right? So configuring Alembic can be done in two different ways. In the Alembic INI, you can actually go manually specify your driver information again and your connection string. Or what I like to do is import the database from my application, pull in its metadata as well, so the first two lines up there. Then there's this section in Alembic where it wants to run the migrations online. I just go grab the config from my application and pull it, and grab this is the string from my application, and then set it equal to the SQLAlchemy URL. What's kind of nice about that is if I change it in my app, it gets automatically updated in Alembic, and I don't have to remember to update it in two places. So again, you can do it in the Alembic INI, where you can define the entire connection string, or you can do it in the environment.py, and you can actually import from your app and pull it in. The advantage of doing it this way, where you pull in the database and the metadata, another advantage is it makes auto migrations work from those two commands. So by pulling in the metadata, it'll automatically be able to map out what you have one versus the other. All right, so let's look at a revision. To create a simple one by hand, we can use just say Alembic Revision and then M, and then give it a message for what we want it to be. So in this case, let's look at a migration where we're going to create a through table that joins the user tables to itself and connects a patient to a provider. It is unfortunate, but doctors do eventually get sick, and people want to know, was the provider actually being the provider, or was he being the patient in a particular case? So what this does is sets up some columns in a table so that we can relate the two together. And it also defines some constraints on that table. And then it also altered another column that we had to set up user-created reminders that were there. So an Alembic migration consists of two pieces. Consists of the upgrade function that we're looking up here that moves us a step forward. And then it also has a downgrade function like this that reverts those changes, right? So in our case, we're just going to drop a table and then alter a set of columns. To tell Alembic to upgrade to the newest version, we use Alembic upgrade head. And then what will happen is it will actually go out and find what point the database is compared to the models, and then decide how many migrations it needs to run to get to current or get to the head of Alembic, and then it will apply all those migrations sequentially to get you there. Autogenic migration is pretty similar. We're just going to add the -- auto-generate onto there. And it will go find tables, adds, removes, columns that were added, removed, and any nullable type changes, right? So if you make a column where it can be null or where it defaults to null, except always, there's a gotcha, right? So you have to, it optionally will find column type changes, right? So if you change from int to string or, int to boolean or something like that, you have to tell it compare type equal true to actually go find that type of change. But it does not detect name changes at all. So if you change the name of a column, it thinks it's net new and it thinks you dropped the old one. Ponder that for a second. Don't learn that the hard way. Learn that now. It will destroy data without thinking about it. So be careful when you're looking at name changes to make sure you actually go check that the migration pulled it across correctly. So let's look at how we can move through migrations, right? So Alembic current just reports back to you the current migration that you're on. It also will show you a branch, and I'll show you in a second what branching looks like, that you're on. You can upgrade 2 steps from where you are. So we have a requirement on an app that I work on outside of work where we have the database must work 2 versions back, right? So any changes we make to the database can't break 2 versions ago of the code. So we use the upgrade and downgrade to go up specific versions and down specific versions during testing. So here you can see we can upgrade 2 versions up from where we currently are, or downgrade 2 versions down from where we are. We can upgrade with just part. So this is a partial match upgrade, this AE1. That lets me just type in the first few characters and it'll go. If we want to just dump the SQL and make sure that what Alembic detected or what I created makes sense compared against the database, then the Alembic upgrade 1 -- SQL will dump that SQL out to the screen. Of course, you can redirect that to a file. And then the last command is Alembic history. And this command is kind of important because it gives me a chance to illustrate a couple of things. So read this from the bottom up. This is the database that started from nothing, and we use migrations every single step to add additional components to it. But notice up here that there's a branch point, right? Remember when I said we keep code that's forwards and backwards 1 or 2 revisions? So that branch point is the point where our code deviated, where our models changed enough where there was a breaking code change. So code prior to that branch point would no longer run on our database. Does that make sense? Alembic actually supports the use of Alembic branch so that you can mark code as this version of Alembic matches this SHA commit in Git, right? So we can say, if you're deploying this, make sure it's at least this Git SHA or future versions of that, right? Does that make sense? So you're matching your database migrations into your commit history, which is pretty awesome because if you roll back before that point, it will roll back the database automatically before that point. So if you're testing something and someone says, there was a bug in this version, if you roll back from that point, it knows automatically I have to move the database back, right? Whereas the way we're set up, if you were going back just to here, it would say, okay, that's good. I don't have to roll back any database changes because that's where the branch point is. Anything before that requires me to actually undo database changes. Now, how many people see something weird in those top 2 lines? Anything unusual? What you got? 2 heads. Yep, Hydra, right? This is an oddity that I hope will be fixed soon, but I wanted to point it out because I think it's strange, at least. The 2 heads is weird. And the reason why there are 2 heads here is, remember how I told you we can keep multiple versions compatible? We have both of those versions are compatible with the current Git head. Does that make sense? So that's the connection, right? So this one connects to a branch point, a tag named branch point in my Git history. Those 2 above it actually work with the head of my repo. Does that make sense? So that's why the duplicate head there. I know that looks a little strange. It gets really weird where you had a branch point that was many migrations ago. And you have like 20 things that are listed like they all connect ahead. That's a little weird. But that's what occurs in that case. And that's Alembic history. All right. One other thing I want to mention about Alembic that I think is just a piece of advice that applies probably to all migration things. Remember to squash those at some point in time, right? When we have new developers come on, one of the things that becomes a little bit problematic is you give them a dump of the database that's current, and then they get all these migrations to run, either through Alembic Migrate or maybe they have manage.py and they're going to dash migrate a particular app up or whatever. Remember to squash those down so that wherever you're currently at, wherever point you might start from, that's where the migrations go. You don't want to end up with this command being like multiple screens of data. It would be really painful. So keep that in mind, that it's a good practice to go back and squash migrations, get rid of them if they are just no longer going to apply, keep the cruft out of the way, and keep the confusion down. Alembic is smart enough to know, in the Django world, there is the -- delete ghost migrations. You guys run into that before? Where it'll go and get migrations that are in the database but not on file and wipe them out. Alembic kind of does that automatically. So every time you run Alembic upgrade head, if there are migrations that you used to have that you've squashed and deleted and gotten rid of, it just goes, oh, those aren't there anymore, moving on. So that and the fake, or not fake, I just said it. The -- ghost delete, I'm sorry, in Django will let you squash those old ones and then make them disappear from disk. And then finally, what about questions? The slides are up on Speaker Deck already. You guys can hit me up on Twitter if you have questions. But what questions do you have while we're here? I know I kind of ran through that kind of fast. Dead silence. That's never good. What's up?
Quick question. How closely can you get code in SQLAlchemy to match actual SQL statements if you're so inclined?
Okay. So
for instance, I were to learn SQL and then start coding, how quickly can you get up and running?
Okay. So the question is, how closely can you match the auto-generated SQL from SQLAlchemy to SQL, and how fast could you go if you knew SQL? How complicated would it be to switch to using SQLAlchemy? I think it's actually easier to use SQLAlchemy than it is to use SQL statements, although I don't find that to be advantageous. I think you should learn SQL first. The reason why I think it's easier is the ORM abstracts a lot of things, particularly when it comes to relationships and joins. It's really easy to say class.address, right, as opposed to select star from users, join on, So I find that to be easier. As far as the generation of the SQL, it's very accurate because a lot of effort has been put into the dialects. So of all the magic that occurs in SQLAlchemy, the real effort is in the dialects, right? Because they decide, when I see this set of instructions, how do I turn that into SQL? And so there's been a lot of effort, particularly on the Postgres one, to make that very, very efficient. And it comes out very close. You can always do a print of the select. So you saw I use the S to store the select statement pretty regularly. You can print that S and it'll show you the SQL it's going to send against the database. And so you can compare about, this is what I would do if I'd handwrite it, this is what it generated. One advantage that it has over some of the other options, the positioning of the filters isn't as critical. It's pretty smart about evaluating. You have this long list. It would be really good if this join was actually over here. It's very smart about evaluating that and making changes. The other cool thing is there's an explain in the Postgres one. It's not in the MySQL dialect, but in the Postgres, there's an explain that actually runs the explain function from Postgres and returns you the result back. So you can say, okay, why did you do this different than I did? And it'll show you the execution path in the database. It's kind of cool.
Can you get the raw SQL back?
Yep, just print the select, and it'll give you the raw SQL. There's also a pretty nifty thing in Core called compiler. You use it when you're writing a dialect. It will actually show you why it made that decision. It'll show you the choices, the options it had, and then what it created. What's up?
What advice would you have for someone who wants to move from the Django ORM to SQL?
Okay, what advice would you have for someone who wants to move from Django ORM to SQLAlchemy? Just try it. There's probably a good chance the commands are so similar that in the ORM mode, most things will just work, right? In the core mode, it to me feels kind of SQL-ish, like you saw my, users.insert.values, like that feels kind of SQL-ish to me, or certainly not as much of an abstraction. But I would say, like many things in Python, you can almost just type it in C a lot of times. Obviously, you don't want to do that with delete statements and that kind of stuff, but print the thing often, or go into PDB and see what it's going to send before it sends it. And then if you're using Postgres, explain is great, or if you're using MySQL, you can have it dump every single command and have you say yes before it actually applies it, which is useful when you're first getting started to know, I typed this, is this doing what I think it does? Yep.
Do you use SQLAlchemy with Django, and if so, what sort of caveats?
Sure. I should have explained better. I'm not one of these guys that gets up like, I'm Jason and here's my life history. But so at work, we do use a Django app, and we use the Django ORM for all of the things that we have models for. But for our data that comes in from states and our data that comes in kind of unorganized from our customers, we like to use SQLAlchemy to query that, specifically because of the unavailable fields and because of the ability to write a dialect to talk to Redshift. Right? We've also written a extension to the Django ORM to let it talk to Redshift as well. Both of those are out on GitHub if you ever run into a need for it. But it's very simple to use. Don't try to replace the ORM with it, I think, is my advice, because there's so much work and effort put into the connection between the Django ORM and the rest of the Django framework that it makes sense to use it. I'm not one of these guys that advocates like you must get everything needs to go to SQLAlchemy, but SQLAlchemy makes great sense as dealing with unstructured data or data that you may not know all the details of. And again, it's pretty easy. You can pip install it and then just import it where you need it. Yes, sir.
So if you're kind of a medium level SQLAlchemy person, but you want to get to the advanced level and really understand how does the engine talk to the dialect and how does the connection pool work, and maybe I need to do some scary things with talking to multiple databases and switching out from each other. Do you have any particular recommendations other than read the source code?
I actually do, and this recommendation came to me last week because of personal experience, so maybe it's just top of mind recommendation, but write a dialect. Like actually say, this past week I needed to add that unload statement to Redshift. And one of the other guys that I work with, Matt, is a genius and I'm not. So I was using his Redshift dialect the whole time and I needed to add unload to that. And I learned more about how the engine actually works and how SQLAlchemy actually talks to the data, how it makes its decisions from just doing that. Just pick a command, thank you. Pick a single statement and then write that in a dialect. You'll learn more than you want to know probably about how it handles it. And there are some tricky things in there, right? So they're doing some neat things in the init method. They're not magic. They're not hidden. They're clearly executed, but there's some neat ways that they access that. And writing the dialect will expose that to you. Other questions? Yes, sir.
How well does Alembic support the transactional DDL?
How well does Alembic support the transactional DDL? I'm going to say it does a fair job. Alembic is by no means south, but I don't think they're trying to be south. I think they're trying to keep it compatible across the ORM and core, and I think that's a difficult task, right? Because they're trying to kind of make the tool a little widespread, and I think it's getting better. The one thing that is great is they accept PRs. Like on a consistent, fast basis, they'll look and review what you've submitted and make a decision. So if you do run into a quirk, it's pretty easy to get them to acknowledge and either accept your fix or help you come up with a fix. They're very welcoming guys on the mailing list too. Any other questions? All right, thank you very much.